Hello viewers, in today's session we are going to discuss an important concept from three-dimensional geometry with the help of this problem. So here we are given two lines L1 and L2 whose equations are given in symmetric form, and here we have to show that these two lines are coplanar lines, right? So here we'll see the concept of coplanar lines, and then we have to find the point of intersection of these two lines L1 and L2, and then we have to find the equation of the plane containing these two lines, right? So let us first quickly see the concept of coplanar lines and intersecting lines. So now two lines L1 and L2 are said to be coplanar lines if they lie on the same plane. Suppose we have a plane pi, and if these two lines L1 and L2 lie on this plane pi, then these two lines are said to be coplanar lines, right? And lines which do not lie on the same plane are said to be non-coplanar lines or skew lines, right? So here we have the line L1, and here we have the line L2, right? So this is L1, this is L2, and this is L1. So L1 and L2 are said to be coplanar lines if these two lines lie on the same plane pi, and we have to find out the equation of the plane containing these two lines, right? Okay, now see here the direction ratios of the line L1 are given by 1, 2 and 3, and the direction ratios of the line L2 are given as 2, 3 and 3. So now if we look at the direction ratios of the two lines, then these two direction ratios are neither equal or proportional. So it means L1 and L2 are not parallel lines, right? But L1 and L2 lie on the same plane, and L1 and L2 are not parallel lines in this case. So these two lines must be intersecting, right? So if the direction ratios of the two lines are not equal to each other, or they are not proportional to each other, then the lines L1 and L2 are said to be intersecting lines, right? So now here this point P may be taken as the point of intersection of the lines L1 and L2, and we have to find out the coordinates of the point of intersection of these two lines L1 and L2. So let us start. So now to get the coordinates of the point of intersection, that is point P, we have to introduce two scalars here. Let us here write lambda, and here we have mu. And lambda and mu are two scalars, and lambda and mu are real numbers. So the purpose of introducing lambda and mu is to get the coordinates of the general point lying on the line L1 and L2, right? So let us find out the value of x, y and z in terms of lambda, and here to get the value of x, y and z in terms of mu, right? So from here we can now write. So we have here x minus 1 over 1 is equal to lambda, will form three equations, and then we have y minus 1 over 2 is equal to lambda, and z minus 1 over 3 is equal to lambda. So from here we have x minus 1 is equal to lambda, y minus 1 is equal to 2 lambda, and z minus 1 is equal to 3 lambda. So from here we have x is equal to lambda plus 1, y is equal to 2 lambda plus 1, and z is equal to 3 lambda plus 1, right? So the coordinates of the general point lying on this line L1 are given by lambda plus 1, 2 lambda plus 1 and 3 lambda plus 1. So the coordinate may be taken as lambda plus 1, 2 lambda plus 1 and 3 lambda plus 1 for some value of lambda, right? And similarly from this equation we can now write x minus 4 over 2 is equal to mu, y minus 6 over 3 is equal to mu, z minus 7 over 3 is equal to mu. So from here we have x minus 4 is equal to 2 mu, y minus 6 is equal to 3 mu, and z minus 7 is equal to 3 mu. So the coordinates of the general point lying on this line L2 are given by 2 mu plus 4, taking minus 4 to the right hand side, and here we have 3 mu plus 6, and from here we have 3 mu plus 7. So now the coordinates of any point lying on this line L2 are given by 2 mu plus 4, then 3 mu plus 6, and here we have 3 mu plus 7, right? Okay, so now if the two lines L1 and L2 are intersecting, right, then we have a common point P which lies on both the lines L1 and L2. So for some value of lambda and some value of mu, these two coordinates must coincide, right? Or in other words, we can say that if L1 and L2 are intersecting, then these two coordinates must be equal to each other, because here we have only one point of intersection of the two lines L1 and L2. So we must equate these two coordinates. So we have lambda plus 1 should be equal to 2 mu plus 4, that is we are equating the x coordinate. Then the y coordinate 2 lambda plus 1 is equal to 3 mu plus 6, and then the z coordinate we have 3 lambda plus 1 is equal to 3 mu plus 7, right? So now we have three equations here, right? So let us now rewrite these equations as lambda minus 2 mu is equal to 4 minus 1, so we have 3. Then here we have 2 lambda minus 3 mu is equal to 6 minus 1 is 5, and then we have here 3 lambda minus 3 mu is equal to 7 minus 1, that is 6. So now we have three equations in lambda and mu. So let us solve any two of these equations, right? So it is up to our choice to solve the two equations. So here we can select equation 1 and 2. So here if we multiply equation 1 by 2, we can equate the coefficients of lambda here. So we have 2 lambda minus 4 mu is equal to 6, and here we have 2 lambda minus 3 mu is equal to 5. So let us subtract these two linear equations in lambda and mu. So we have now minus 4 mu plus 3 mu, so this is simply minus mu, and 6 minus 5 is 1, so the value of mu is minus 1. So let us substitute mu is equal to minus 1 in equation 1 or equation 2 to get the value of lambda. So we have here we can take equation 1, so we have minus 2, and here we have minus 1, here we have 3, lambda plus 2 is equal to 3, so this is 3 minus 2 1. So we have now obtained the value of lambda as 1, and the value of mu is minus 1 from these two equations 1 and 2, right? Okay, So now let us substitute the value of lambda and mu in equation number 3. So if the equation 3 is satisfied by these two values, then we can claim that this point P is the point of intersection of the two lines L1 and L2. So now lambda is 1, so we have 3 times 1, then we have minus 3 times minus 1, and here we have 6. So this is 3 minus minus plus here, and we have 6, and 6 is equal to 6, right? So it implies that the values of lambda and mu satisfies the third equation also. So we can now claim that this point P is the point of intersection of the two lines L1 and L2. So now to get the coordinates of the point P, we can substitute the value of lambda and mu either in this coordinate or this coordinate, right? So we'll take this one. So here lambda is 1, so we have 1 plus 1, then we have 2 times 1 plus 1, then we have 3 times 1 plus 1. So we have now here 1 plus 1 is 2, and this is 2 plus 1 3, and this is 3 plus 1 4, right? So the coordinates of the point of intersection of L1 and L2 are given by 2 3 and 4. Now if we take the value of mu as minus 1 in this coordinate, then also we'll get the same coordinate, right? So let us here substitute mu is equal to minus 1. So we have minus 1 plus 4, then minus 1 plus 6, and then 3 times minus 1 plus 7. So we have now minus 2 plus 4, this is minus 3 plus 6, and here we have minus 3 plus 7. So the coordinates of the point P are 4 minus 2 2, 6 minus 3 3, and 7 minus 3 4. So these coordinates are same as this coordinate, right? So this is how we can show that the two lines are contained by this plane pi, or these two lines are on the same plane, and these two lines are intersecting lines, right? And here the point of P, the point of intersection, that is P, has the coordinates 2 3 and 4. So what we have done so far, we have the two lines L1 and L2, and here we have obtained the coordinates of the general point on these two lines L1 and L2, and we have equated the two coordinates, and we have formed three equations, and we have solved the two equations to get the value of lambda and mu. And if the value of lambda and mu it satisfies the third equation, then it implies that the two lines are intersecting, and we have obtained the coordinates of the point of intersection of the two lines L1 and L2 as 2 3 and 4. So now let us find out the equation of the plane containing these two lines, right? So since these two lines are coplanar, so let us find out the equation of the plane pi which contains these two lines L1 and L2. So now to get the equation of this plane pi, we'll make use of this concept, that is equation of a plane passing through three non-collinear points. So if we have the 3 points x1, y1, z1, x2, y2, z2, and x3, y3, z3, then the equation of the plane passing through these 3 points is given by this determinant, that is x minus x1. Here we have x2 minus x1, then we have x3 minus x1. Here we have y minus y1, y2 minus y1, and here we have y3 minus y1, and here z minus z1, z minus z2 minus z1, and z3 minus z1, right? So the equation of the plane pi is given by this determinant is equal to 0, where x, y, and z are the coordinates of any point lying on this plane pi, right? So now let us see the coordinates x1, y1, z1, x2, y2, z2, and x3, y3, z3, right? So now see, here we have already one point, that is P, which is the point of intersection of the lines L1 and L2. So this is 2, 3, 4. Now let us look at the equations of the lines L1 and L2. So now see here, this line L1, it passes through the point 1 comma 1 comma 1, right? So the point 1 comma 1 comma 1, it lies on the line L1. So we have one point as 1, 1, and 1. Now this line L2, it passes through this point, that is 4, 6, and 7, right? And here the third point is the point P, which is the point of intersection of L1 and L2. So we can here write the point 2, 3, and 4. So now we have 3 points, right? So this point is the point of intersection of these two lines L1 and L2. 1 comma 1 comma 1, it lies on this line L1, and 4, 6, and 7, it lies on the line L2, right? So here we have used this concept, that is the equation of any line is given by x minus x1 over a, y minus y1 over b, and z minus z1 over c. And a, b, c are the direction ratios of the line, and the line contains this point, that is x1, y1, and z1. So here we have 1, 1, 1, 1, 1, 1, and then in the line L2 we have the point 4, 6, and 7. So now 2, 3, 4 may be taken as x1, y1, z1, and 1 comma 1 comma 1 may be taken as x2, y2, z2, and 4, 6, 7 may be taken as x3, y3, z3. So let us substitute the values of these coordinates in this determinant. So now we have the equation of the plane as x minus x1. So x1 is 2, so we have x minus 2, then x2 minus x1. So we have here 1 minus 2, then we have x3 minus x1, that is 4 minus 2, right? And then y minus y1, so we have y minus 3, then we have 1 minus 3, and then we have 6 minus 3, and then we have z minus z1, z minus z1 is 4, and then we have z2 minus z1, so z2 is 7, so we have 7 minus here we have 7, that is 1, right? So we have 1 minus 4, then we have 7 minus 4, right? And this is equal to 0, right? So substituting these values in this determinant, we have now this equation. So let us simplify it. We have x minus 2, 1 minus 2 is minus 1, 4 minus 2 is 2, then y minus 3, 1 minus 3 is minus 2, 6 minus 3 is 3, then z minus 4, 1 minus 4 is minus 3, and 7 minus 4 is 3, and this is equal to 0. So now we have to expand this determinant to get the equation of the plane pi. So now expanding along the first row, we have x minus 2, and then we have here minus 2, 3, minus 3 and 3. Then we have here minus y minus 3, and then we have minus 1, 2, minus 3, 3, and then we have z minus 4, and here we have minus 1, 2, minus 2 and 3, right? So by the concept of cofactors and minors, we can expand this 3 cross 3 determinant of order 3 like this. So we have x minus 2, here we have minus 6, then we have plus 9, then y minus 3, and here we have minus 3, then plus 6, and then we have z minus 4, and minus 3 plus 4 is equal to 0. So now we have x minus 2, 9 minus 6 is 3, y minus 3, here we have 3, and then z minus 4, and 4 minus 3 is 1, right? So now we can here simplify this expression. 3x minus 6 minus 3y plus 9, then z minus 4 is equal to 0. So this is 3x minus 3y plus z, and 9 minus 4 is 5, 5 minus 6 is minus 1. So this is the required Cartesian equation of this plane pi, and this equation of the plane is of this form: ax plus by plus cz plus d is equal to 0. So this is the required equation of the plane pi, which contains these two lines.